Okay, let's get started. So my name is Sahas. What do you see? That's my full name. I don't know who here would be able to relate anything to it, but um, so I work as an architect in a company called CDK Global. Um, that's and then you know I'm a Google Cloud kind of enthusiast. We started this meetup kind of second session now, right? I use various aspects, whatever we're going to talk today, and beyond that, I use most of these Google Cloud products in my projects. Um, as a developer, at heart, right? That's what we do all day, right? It's even though at the different you might end up playing different roles in your job as a some days systems engineer, some days developer, some days as a tester, some days as a DevOps guy, but at heart, developer. So I tried all different cloud providers, AWS, Azure, and Google Cloud, and kind of landed in Google Cloud. Um, um, was pretty impressed with the ease of Google Cloud from a developer perspective, right? How easy it is to get started, how easy it is to see some output, um, and how reliable their infrastructure is, and so on. So we're going to talk about Google Cloud App Engine. App Engine is specifically their infrastructure as a service. Um, Platform as a service. So like any other Google provider, cloud provider, right? Every cloud provider provides infrastructure as a service, and then platform as a service, and some of them software as a service, right? So last meetup we talked about holistic. What is Google Cloud? What are different aspects of Google Cloud?
Speaker behind him is causing the feedback.
Something
Do
here.
you have a speaker behind you?
Me?
So when you talk,
Oh,
every
okay.
speaker
So
comes
I'm
back.
abstracting the speaker.
Yeah,
Okay.
you're talking back to yourself.
Oh, okay. So let me try to move.
If you move away, it's going to be
Okay. So we'll see. Um, so yeah, sure. So App Engine is specifically platform as a service, and it's been they claim it's been made more friendly for microservices oriented architecture, right? When you talk about microservices, I thought we should talk about monolith first, meaning we should know what is a monolith and what are we trying to do with microservices, because pretty much wherever we go, microservice is a very hot topic, right? Distributed systems and microservices. I can't imagine an organization that doesn't talk about it. That's kind of pretty much de facto. So monolith is like, yeah, you have different, you have an application, say for example, a shopping, application. You have a shopper, admin, or different persona, different roles. Everything is kind of bundled into one application, one deliverable. All these modules, be it your search or authentication, authorization, or order processing, or payment processing, or notification, everything is kind of lumped into one big deliverable, right? That it gets delivered, and it runs as one big system. And I'm sure many of us work in systems like that. I mean, I interact with a system like that every other day. Any company that grows over time, they probably started with this maybe 10, 20 years back, and they're trying to migrate over from this. Right, what is the problem? It works. Yeah, it doesn't mean it doesn't work, but is there an opportunity to be more efficient? Um, it's hard to develop, right? And if you touch any piece of this, the whole thing has to be deployed again. The whole thing has to be tested again. The whole thing has to be operated again. So it's kind of natural. It brings in natural deficiencies along with it, right? That's when people started talking about microservices, where you kind of there are many different approaches. How you kind of split your large monolith into to something logical, um, There's a I kind of follow something called domain design, where you kind of think about a particular domain and based on domain constructs, you divide your system into multiple systems. Say, sir, in following the example that I talked about in the previous slide here, I kind of divided that into different systems like search. Our common is kind of common shared services across different places like your authentication and authorization, our notifications, right? AI, artificial intelligence, or order processing, or payments. They're kind of so you kind of divide the whole monolith into different subsystems. And what happens is now, because they are they are small, they get developed on their own pace. They get deployed on their own pace. They can scale based on the demand. In say, for example, common might run with say 2 nodes in production, whereas search might run with 8 nodes in production. Depending on the volume that you get from your customers, it can grow on its own automatically, right? So it gives you that flexibility. It is easy. I wouldn't say easy, but it's better to develop. It gives you more flexibility. Like I can write, search can grow for its own market. You can integrate with, say, Google search. You can integrate with Bing. You can integrate with anything and kind of grow that side of the product, right? So it brings in a lot of advantages, but then the problem, everybody, all of us have this idea that, yeah, once I start breaking this apart, it's easy. Everything, I had like 100 lines of code. Now it becomes like each one of them have, say, for example, 10,000 lines of code. Build is like, it used to be like 4 hours. Now it is all 10 minutes. It's easy. But then now there's more interaction happens with across different systems. If you don't have strong contracts, it's going to be hard for us to predict the overall system health, overall reliability, and resiliency. While it gives us the scale, it doesn't come with the resiliency patterns, right? So that's where an ecosystem is important. When you talk about microservices, you need to keep many concerns in mind. For example, you should be now we have. At some point, we used to have one big box where everything was running. It was easy to even collect logs, easy to collect metrics, easy to learn about the system health, easy to learn about application health. But then now we divided everything to separate things. Now, how do you really go and collect different logs and make something out of it, right? Centralized logging becomes a more important piece. Centralized metrics becomes more important piece. And when transactions, say for example, as a customer, I'm trying to buy something, and I am, I'm searching, and then I'm placing my order, and it goes to payments, and then it goes to payment gateway, and then it goes across different systems. So distributed tracing, right? One customer initiated some transaction, it goes across different systems. How do I really trace that particular transaction across different systems? If we don't have that ability, that's going to be, we're going to be in trouble, right? It's going to be hard. We're going to be less efficient, and of course, deployments will be shorter. But then you need to know if, say, for example, for this search service, it needs authentication and authorization. So how do you know if authentication and authorization is up and running always, or how would you behave when authentication and authorization is down, right? So it brings a bunch of these concerns into picture. If you don't have a good ecosystem around it, it's going to be a nightmare. It could fail, and developers would spend hours and hours and days to figure out the costs when there's a failure, because we don't have centralized logging, or we don't have good distributed tracing, or we don't have, we did not really think about a fault tolerant or resilient design patterns into picture. Your fault can, or the failure can cascade into, say, for example, authorization is down. It can bring the whole idea that the monolith, if anything is down, the likelihood of the whole system halt is high. But with microservices, that possibility is low, right? If anything goes wrong, well, it might not affect the other system, but the other system cannot function too. When authorization goes down, when payment goes down, when a customer searches and adds some item to cart, when they want to check out, what would you do? if we don't have right resiliency patterns, we're going to be in trouble, right? So that's where AppEngine comes into picture. AppEngine is a platform that gives many of these out of box and enables you as a developer to go and start writing code and not worry about many of these concerns. So how does it? So it's it's a pretty good backend, very solid backend for web apps and mobile apps, and it's fully managed by Google. You don't care about where it runs. You don't care about how it runs. You don't care about how many instances do I need. You define your desired state. You're saying I have my search, right? Search as a capability. If my search gets to a point where the CPU usage is, I'm running complex algorithm, my CPU usage goes beyond 75%, add another instance, bring up one more so I can serve more customers, right? When it goes below 25% usage, keep it to two instances. I don't want 8 instances. So you're saying you're doing, you're defining your desired state, how you want your system to be, and App Engine will take care of it. We'll see that in the demo. But it comes with, say, when you start talking about application, you're not just talking about web app. You're not just talking about writing some REST endpoints. You're also talking, you might want to write something to a database. You might want to write something to, say, a queue. You would want, you might want, say, a NoSQL database for some operation. You might want a SQL database for some operation, right? So App Engine comes with some of these, so we don't have to spin up boxes and instances and write Puppet modules and manage that, right? So App Engine comes with all these, like your memcache or blob storage or logging and tracing, distributed tracing and everything. They provide a couple of different environments. One is called standard, that provides us Java, Python, PHP, and Go runtimes. If your API is from one of these, there is more specifics in the next coming slides, but about the versions. But then, if your runtime is like Java, Python, Go, and PHP, you could very well use the standard environments, and they provide you auth and data store and memcache and all those out of box, and auto scaling and load balancing is taken care of. Like I said, so you can define characteristics like if my usage goes beyond 75%. CPU, go and spin up another instance for me. You don't have to worry about the load balancer. You don't have to worry about, do I use Nginx or do I use Linkerd or do I use something else? You don't really care about it. It's taken care of by the platform, right? And it comes with task queues to manage your, manage something that beyond. Say I want to send 3,000 emails. When somebody clicks a button, I want to send those many emails. I don't want that customer who clicks a button to be waiting until the emails are sent. I can just put it in my queue and process that. So I don't have to stand up another RabbitMQ instance just for that purpose. App Engine comes with out-of-box task queues. They call it pull queue, push queue. You can leverage whatever is appropriate for you, and when you when you define your CPU and memory, expectations, they determine what kind of instance class you want. Is it A or B or C, and they spin up those many instances for you. So it's kind of pretty much abstracted from the user. Then if you are using some other runtime other than Java, PHP, PHP and Go, right? Python, Go. Say, for example, I'm using Node.js. What do? There's another type of environment called flexible environment where you can bring in your own operating system, your own runtime. You can bring in your own libraries, and they will still operate that the same way. It comes with auto scaling, task queues, memcache, whatever, right? Almost all the features that standard environment provides. Plus, on top of that, I can run my Node.js workload. I'm not sure about the Windows side of the world. I am 99% positive that it's not supported, but I don't know. So with those two are the environments If you look at it, this is the standard environment and versions, like they support Python and Java 7. For example, you need Java 8, probably you got to go with flexible environment. Flexible environment, I think it's in beta stages by now, but Gmail was in beta for years. Yep.
What version of Python are we? Is it 3?
Python 2.7 is supported in standard environment. Anything above 2.7, you need flexible environment. So there's no real, I don't know.
So there's no support for Python 3?
There is, yeah. You can bring in your own version. Like you can say, I want to use Python 3, and you will just pull the flexible environment, not the standard environment. We'll see. The standard environment is nothing but they run a pre-configured containers. If you look at it, in flexible environment, you're running your own. You can bring in your own container. Like you can create your own Docker file in container Python 3, and you can run that. And you can still operate that in Google Cloud AppEngine. It'll be the same as Python, say 2.7. Almost.
So you have to create your own
Yes,
container.
correct. And that being said, there are a lot of those containers provided to you by the community already. I'll show you one. Like say I'm going to use Node.js example. I did not create that container. I'm saying, okay, pick Node.js, a particular version. It's going to pull it down, create a container, throw it out, and operate on that. So it's already, most likely it's given to you. Good. So that's kind of a little comparison between standard and flexible environments. And then how does it really work, right? It's all good. It's a standard or flexible environment. Now I have my workload. How does it really work? I don't know how that works, right? What happens is, so let's say you have a project called demo, right? That project, then it's gonna, within that project, remember we were talking about microservices, right? That project or product, I should have named it like product, right? Say product, say whatever, basic, I'm making something out of Amazon, right? I have search, I have order processing, I have payment processing, all those. Now, all those become separate services, right? You have a common service that provides you identity and authorization and notification, anything common. You have orders services that helps you to process orders. You have, say, AI that helps you to do, say, voice recognition or machine learning projects that you have. A payment service that talks to different payment gateway like PayPal and others, right? So all these become services. Each service you can have your own versions. Like you have version 1, and you add some more code, and that becomes version 2, version 3, and each version, all these versions can coexist underneath the service. And when you want to hit the service, it is resolved from right to left, saying, okay, go to demo.appspot.com. That's Google Clouds. From within demo, go to the service called orders. From within orders, go to the version called v1. So, if you follow the pattern, your calls from UI or external service will reach that particular version. And like I mentioned, AppEngine comes with a bunch of shared services, including Memcache or Data Store or Blob Store. If you want to store your blobs, documents, right? Database, NoSQL, SQL database, they offer out of box like a fully managed SQL and NoSQL and everything. In reality, from a user perspective, you have your own, you have your code when you deploy. It gets deployed to whatever environment, be it flexible or standard. And within that, you have a VM. Within that, you have Docker container, and within that, you're running your app. So you have multiple containers. So equate this container to these multiple versions. That's it. You have a container for each version, and they coexist, and their routing logic takes care of routing the traffic.
This is probably one of the major difference between other cloud providers, where these guys did version as a first-class citizen. But for other cloud providers like Elastic Beanstalk or whatever, it's basically like only during the deployment you can use one version, but you cannot co-run two versions of the same
Right,
in
right.
a native version.
Yep, yep. So this here even it gets more, I would say, easier from a developer perspective. I can run my A/B testing. I can run my other, say, canary testing, whatever, and say, okay, send a percentage of traffic to V1, another say 50% to V2, and based on the results, start increasing the traffic to V2. It's all, you can do all those. It's very intuitive. So then that's how it looks from outside. So as a developer, I update my code and deploy. This whole thing within whatever happens here is taken care by AppEngine. That's the power of AppEngine. All right. So how do we really make it happen? What happens under the hood? It's kind of managed by number of configurations. So as a developer, or even within the organization as a DevOps group or systems engineer, you might end up either leveraging this or adding more, maybe a wrapper on top of this, literally, right? Say, for example, here, this configuration. So within each application, right, you have a, say, dispatch.yaml file that helps you to customize or change your routing rules. Like I said earlier, the routing happens like this. This is the default routing rule. If you want to change it, go and define it here in the YAML file. AppEngine will take care of that. And then underneath, you have different services running. Like this is payment, this is order, this is search, right? So under each service, you have the source files, like src directory. And you have a YAML file again. That's where you define what is the desired state for this particular service. Say, let's consider this as a search, and this is order, right? And the third one could be payment. And for payment, I may have two different configurations. If it is a PayPal payment, do this way. If it is anything other than that, like MasterCard and Visa, I'm using two different gateways, and I want that to be in a different scale, right? I can define as many as configurations I want, and it'll, and the configurations are nothing but saying my desired state. Like here's an example of app config. App config is nothing but this within the service. So consider this as a service. Say I'm saying this service is payment, and runtime. You can define your run. Is it Node or Java, PHP, Python, Go, whatever is the runtime that you want and the version that you want. You're saying that, and you're saying, okay, once I deploy, enable the health check. I'm saying don't worry about that. And here's the interesting piece, right? Auto scaling. What I'm saying is start with minimum instance number, one instance, go up to 10 instances. And when you scale up, the cooldown period for scale down is like 120 seconds. When do you want to scale up? Once it hits the fan and stops working, once it's dead, or do you want to proactively scale up, right? Once my CPU utilization reaches, say, 50% in payments, I don't want to miss a payment just because my there's a leak, or there's something, garbage collection going on, something going on that's eating up my memory or CPU. I don't want to lose a payment. So let's, if it's going beyond 0.5, which is 50%, go and start scaling up, right? So that's all you do. This is your desired configuration. I think they take this, operate using Kubernetes behind the scene, and provide this to Kubernetes. This is the desired state that you're saying to the AppEngine, saying, okay, at any given point in time, I want you to abide by this. If CPU usage goes to 0.51, I want you to spin up a box. If its CPU usage comes below 0.5, say 0.49, I want you to start scaling down, right? That's all you do as a developer. Literally, that's all you do. That's nothing more. Nothing more, nothing less.
So we're trying to be things going with Kubernetes, trying to make it stateless as possible, right?
Yep. So they operate inside. They operate Kubernetes. Bring up their pods and start provisioning your containers and start running your workload. And they have etcd as their they have different. Kubernetes itself is a pretty good. If you look at the Kubernetes architecture. Probably we'll have another session sometime. That itself is a good distributed systems architecture. They have scheduler, they have etcd. That's where they put the desired state, and then they have something called kubelets. Hey guys. So from there they have a number of kubelets which will listen into etcd configurations and make sure that your system meets the desired state. Right? Grab some food.
Just ate.
I know.
Yeah.
Alright. So there are like we just talked about app.yaml, right? Application configuration, where you define how your application should behave, and say application may not be just API all the time. It could be a bad job that you're getting some data dumped from another provider. You might want to process that at a given point in time, like a scheduled job or a cron job, right? So you would define they have given a bunch of different variety of YAML files where you can define those to run scheduled jobs and the dispatch. We talked about it. That's more of a customizing your routing patterns. Queue, of course, whatever task queues that you need for your application, and index YAML is talking about the data store. Say at runtime your AppEngine wants to put some data into data store. You don't have to spin up another cluster of Gemfire somewhere. It's in memory and data store, NoSQL data store given to you. Leverage that at runtime. So when they spin up the environment comes up with necessary APIs and modules to support all these. That's it's all out of the box, right? And then so it's interesting, right? Now how do you really operate on that? Google Cloud SDK offers command line interfaces, and it's pretty much they provide RESTful endpoints as well. You can directly talk to AppEngine through the REST endpoints, or if we, of course, to automate it from your continuous delivery or CI tool, Jenkins or Bamboo or whatever it is, gcloud SDK. We can do everything from, say, I can list my instances, whatever VM instances I have, or bring up more instances, look at more versions of my app, start the app, stop the app, and take it out for maintenance, and anything that we do with typical container to build application can be done through this through the CLI support. That's kind of at a very high level. Now what AppEngine offers, right? It's not just backend API. Anything that you need for your API to be successfully operating, including say queues or your database or your memcache. Say I have my search engine. Somebody's searching for a specific thing on that particular day, and if that same search is getting asked a number of times, I might end up using my memcache, so that my memcache is nothing but you have that cache in your memory. The response goes back to the same customer, so your app doesn't really suffer by the load. So they give you a load of all everything that you need as an ecosystem to operate your APIs. That's what AppEngine. It's not just a way to run your API. Alright. I think that's then the demo. Usually it doesn't work when you demo. Let's see if it works. So I created a GitHub repository. So what it has is so it's a Node.js workload trying to run a Node.js Express server. It's not super different than any other RESTful service that you're trying to operate. Could be Java, PHP, Python, or not .NET, but anything other than .NET, right? That's literally it's a Express server, and it has a bunch of stuff behind it. So let's say
Color.
how do I change it? I'm a default guy. Do you want me to increase the size or change the color?
Oh yeah, the size is actually this better. Yeah.
Okay, all right, cool. Hopefully it sticks.
Awesome. Lights, I think.
Yeah. We'll do that.
Someone's gonna go to sleep.
Okay, cool. So like I said, it's a Node app. Don't worry about all the dependencies and everything. You know, all I'm going to say, it's a Node app runs based off of Express. That's all you need to know, right? Don't worry about other things. It's like how do you build, how do you deploy? It's all that stuff built in here. I look at the source. I have it starts here. I'm going to run the app in whatever available port. I think it's going to be 3001. It's going to, so I have commented out a bunch of things. This came out from my, sorry, I need to increase the font size. Let me see, how do I do that?
Just do Command plus.
Command plus. Okay. Alright, so it came from some of my existing seed. I work on Node a lot, so created a seed project and start off that all the time. So I just pulled that off the shelf and lumped it here for demo. So it's using a bunch of good patterns, I would say, meaning, say for example, it's Express Server, I'm using Bunyan for logging, and I'm using something called Helmet. That is not that what happens is, say when you run any web server, right, be it Java or any runtime, when somebody hits your web server, in response headers, it'll tell you what kind of web server it is. By just seeing that what kind of web server, you're kind of inviting people to, it's easy for them to figure out what kind of web server you're running behind Apache or anything else and start attacking you, right? So it kind of, Helmet is a library in Node.js that helps you to avoid a bunch of those type of situations. It'll mask some of the information, like, okay, they don't even know this is either is it Apache or Express or IIS or Nginx. The consumer who's trying to hit your API doesn't even know what kind of engine that runs behind it. So with possibility of attacking your app is less. So that's why I'm using Helmet. And then obviously I'm using rate limiting, meaning if say one from the same IP, same user who's trying to access the API like more than 100 times in a millisecond, which is highly likely, say a DDoS attack or something like that. So trying to limit that using rate limiting, etc. So that's why you would see a bunch of code here. See this whole thing, Helmet related code, and then I'm using, let's go to the router. The routers, I just have, let's say, health check. I'm delaying a response by say 1 second. And then I have some functionality here, like say because I wanted to show auto scaling, I need something CPU intense. So I thought recursion is a famous CPU intense stuff, right? So just create it doesn't do anything. It's simply runs a factorial. If you say factorial 1000, it's going to put some load on CPU for sure. So I wanted to show auto scaling and then picked this simple code. So that's all it has. It doesn't have, the app doesn't have anything else, right? So simply what do we have to do? Let me see. Okay, remove. I am connected, so I can remove. So I'm just deleting whatever I have. Right. So prerequisite, if you go through the page, you will see you need to set up Google Cloud SDK. Download the SDK and set it up with your Gmail account. When you do init, it will start initializing your command line. That's all you need, nothing more. And then it's installing all the dependencies. So once that is done, all I'm going to do, I'm installing my dependencies needed, and I'm going to run the app. We're going to hit these endpoints. When we hit this third endpoint, we'll see there's a little bit of delay, and then we're going to deploy to gcloud. And then after deployment, if we start hitting this, and then that'll start auto scaling. That's what we're going to see. That's what I'm expecting, at least.
Hope. That's what you're hoping.
Yes, yes. Google Cloud has not failed me in demo, so we'll see.
No.
Yeah, I'm not even a piece of peanut for whatever they do. So this is nothing. So npm run watch. So we're going to run this local. Okay, so it's running on port 8080. Let's see. All right, it's returning me something. I don't use Fiddler, I'm just using command lines to check if it works. Where's the other delay? All right, came back after factorial /110. All right, so this was quick though, because local doesn't have any load. If I say, oh, okay, it returns null, so it probably exceeded the call stack. Right, yeah, it's a Stack Overflow. So, but it works now, local, right? So with that, let's say, so how do I deploy this to Google Cloud now? If you go to the package JSON, you will see something called deploy. All you need is this command. So go gcloud app deploy. So like I said, if we run, say, gcloud, right? That's, did I? Okay, let's see. gcloud should give me okay, account configuration, there you go. Okay, so let's say gcloud app deploy. Now it should start taking your whole app, like I said in the presentation, right? All it's going to do is pretty simple. It's going to look at my configuration. My configuration, let's see, we didn't show the config, right? So app.yaml, it should be on the root. All I'm not even, huh? Am I looking at the wrong app YAML? Okay, let's look at it. So it should be on that along with the source. It should be on the root. So all I'm saying is exactly the same that you see on the slide, right? It's node runtime. I need maximum. I can tolerate up to max 10. Scaled instances. If the only change is like if the CPU utilization goes beyond 20%, I'm saying scale it just for the demo sake. But in reality, you can add it to 50%, 75%, or 80%. In my real applications, I have it at 80%. If the CPU utilization goes beyond 80%, start auto scaling, right? That's all we have. Now, when I run this command, it's asking me like, yes, do you want me to go and start deploying this? I'm saying yes. It says this is the first time. It's going to take a little bit of time. And what it does is like if we go to Git, we should see really what it does. Generally, they do that. Okay, looks like they changed their command lines. So let's see. So what they do, they take your package JSON, compile, and generate your, say I wrote the code in ES6, so they transpile that to ES5, get your executable, take the whole thing over to Google Cloud. create the instances. Now they created the image, as you see, they created the Docker image. Before that, they will, let's go up all the way to see here. Okay, the step one, they're pulling out this Node.js container. Like I said, you're asking the difference between standard and the flexible environment, right? So standard environment has this same container. Flexible environment also, they provide similar containers. If you don't have a container, create a one and deploy to say Google Cloud Registry and start using your say Python 3 or 3.1, whatever version you want. So they go and pull the container, and then they install Node 5.2 because that's what I mentioned in my configuration. And if you look at my package.json, you would see I am mentioning what is my, it should be there for sure, yeah. So this is my engine, right? The same way you could say Python 3.1, whatever you want, and they install that, and then they copy the whole app. The whole app is the compiled source code, whatever you have. Then they deploy this to Google Cloud and start operating on that. That's it's very pretty much a black box. But then they used to show this. They used to put this stage all this thing, right? The Docker file and the Docker containers and the images that they create, everything. They used to stage it in the same location. So you can see if you go to the Git status, if you look at the Git status of this place, it used to show that. Now it's not. Let's see. Now it's here, right? Git repository is here. So if we say became a little smarter now. Let's see what they say. I don't think they're going to show here. It's all 3 local branch commits. Nope. So it used to show at some point. I that's how when I started. That's how I learned like what these guys do. It's a black box. What they do behind the scenes, right? They create all your containers. They have their own Docker files, and then upload that to containers, and also they operate on Kubernetes. They show you all the Kubernetes configuration as well. That should once the deployment is complete. If we flip over to Google. console.google.com. Hopefully we should see, so AppEngine, services, these are all various services that I have, but then I think this is deploying to the default service, right, updating the default service. So if I go to my versions, see this is the one that's getting deployed now as we speak, 7:03, 15 p.m. And I was talking about the A/B testing, right? Based on the versions, using command lines, we can start splitting the traffic, saying, okay, I'm deploying a new version. Now, by default, if you don't specify anything, as soon as the deployment is done, it will start routing all 100% traffic to it. But then we can customize that, saying, okay, send only, say, 10% of the traffic to the new version, keep 90% here, and then you can do your A/B testing, and based on analysis, you can say, okay, now, once you reach this threshold, start sending more traffic. That's very much obvious. Split traffic is nothing but or you can come here manually and say, okay, for this version, send me this, say old version, right? I can, start configuring this traffic here. Or based on the cookie, I can say, okay, if you see this particular cookie in the cookie, when you test in the cookie, you can start sending a version or git commit, because literally all this, if you look at this guy, this is your git commit hash. So you can send the git commit hash in the cookie, and then the traffic goes to that version. So it's all kind of handled within the platform for us. And behind the scene, they use Nginx and Kubernetes. While it's deploying, if say, for example, I'm going to start hitting the service. I don't know the service name, so let's see. Okay, this is the service name, right? We had that in the README. Okay, so what I wanted to show is like I wanted to run a load test and show the auto scaling. Let's see if we can simply hit the service HTTP this. Okay, that service is up. Let's go and while the new version is getting deployed, what I wanted to show is like how to get to the logs and how do you can also debug. They use something something called Stackdriver. It is again part of the platform itself. Once you deploy your code, if you std out anything, Stackdriver catches that and aggregates all the logs from all the nodes and instances that you have for that particular service. So now if you look at it, I can go and say, okay, my application default service, it has many versions. Each version has its own instance, but give me all the logs from this particular version and different type of log. Like, do you need Nginx? Do you want to see what's going on with Nginx or the system or the application, right? So now I'm saying, okay, I don't care about Nginx. I know it's up and running. Just show me the std out. I'm going to say filter my logs by say delay. Okay, tell me when somebody hits my delay endpoint and show me continuously. Now go back and run delay here. It's waiting for 1000 milliseconds and then it responded after 1000 milliseconds, and I go back. I am expecting that to show up here unless the version switch has already happened. I'm looking at the particular version here, right? Not all versions. If I say all versions, there should be an option to say all versions.
Yeah, we're next to your mouse.
Right next to my mouse. Alright, looks like Stackdriver doesn't work during demos.
Oh.
Alright, it does. So it's pretty powerful, but then they lump all the message in all the context that you std out into one particular node. I think it's in inside the resources. No, I'm not. This is given to us, meaning I just hit the endpoint, right? I'm not doing any std out on my endpoint. If I put, say, like in JavaScript, you do console log, right? The same way, if I do console log here, for example, in my code, if I go to that particular service and delay, if I say console log, right, test, right, this test would appear inside this in one of the nodes, and they lump everything into one message. It's not as intuitive as compared to, like, say, Elasticsearch. You can write your log stash, growth patterns, and split one gigantic message into multiple fields, and you can query by those fields. It's not that intuitive, but at least it gives the logging aggregation out of box. You do nothing, it's just, you get good logging out of it. Let me go back and see if it really deployed and started routing traffic. Yep, it's right now we have 2 instances. So the test that we wanted to run is here, right? So I'm trying to use Apache. I don't know how many of you know Apache Benchmark is a quick, easy load testing tool. So I'm gonna do factorial. So I'm saying I want to do I want 10,000 requests with 100 concurrency. This should ideally put some load in the system and start showing the auto scaling. That's the expectation, right? 100 concurrent users are hitting, and everybody's asking for this factorial 110. And like this, you're going to get like 10,000 requests. So let's see.
All the requests are coming from your machine.
Yeah. It goes from the same box, because I remember I commented out all the rate limiting.
Okay.
I know somebody like me will be trying, so all my APIs have rate limiting. If you are trying to hit my API more than 10 times in a millisecond, you're not going to get any response, right? So, but then I commented that code out, so all this will go through. So now it's sent, 2,000 requests are in. If we go to our AppEngine instances, remember we had 2 instances. Hopefully this will start growing. I saw that growing last time, and I hope it does. There you go. So the third instance, because of the load, it started spinning up the third instance when the load goes up, like say 4,000 requests. Now I asked for like 10,000 requests, so I'm hoping it's going to show up like say 7 or 8 nodes, 8 instances. And once the test is complete, like 120 seconds is what I mentioned as a cooldown period. But I think the platform will take a little more, maybe like up to say 5 minutes or so, to bring it down to whatever is default. The default, what I asked for was 1, so it should come to that. All right. So yeah, I think that's kind of what I planned to show, but we can explore. We have time.
How long does it take for it to spin up another instance?
It is spinning up right now. It's seconds. Seconds. It's not even minutes. It is within seconds. If I refresh, you will probably see more. See?
Oh, okay.
So it's not, this UI is not pulling actively, but then it's not even seconds. That's the commitment from Google. It's fairly fast, but then cooldown time though is not as fast as they spin up. Cooldown takes scaling down takes a little longer. I think for you it took like 5 minutes.
Yeah.
For me it was like for me it took more than 20 minutes or so. I don't know why, but
Yeah, I'd worry more about scaling up than scaling down.
Right. Cool. So because this is more of a custom, right? It's not a standard environment. This is our flexible environment. What they let you do is like you can SSH into the box and you can do whatever you want. So that's how I found that what do they do internally, right? You can go and see whatever you want to explore, what kind of tools they use, how do they configure Nginx to be auto scaling. You have full control. That's one of the reasons why I use flexible environment, just to go and explore and see how they really make it happen. In a standard environment, they don't let you touch because it's their own thing, right? So I mean, so yeah, that's what I wanted to talk today. Oh, it's got stack driver right now. Where did I log in?
Should be some goals.
Yeah, I think so. It's blocking. Otherwise, they do have Kubernetes and kubelet and everything installed, and it's operating from this box. All right. So, any questions? It's easy. Go to GitHub, pull this down. I hope it's just as easy as I did. If you follow this, it should just work and let you enable you to host your next app. And I think.
You put the GitHub
Uh-huh.
on the Vita?
Yeah. We'll upload that. Upload the slide deck into. Yeah.
I have a question.
Yep.
You have a router.js file which has the Express API settings for configuration.
Right. Yeah.
How does Google Cloud know that it should go to that file?
So it's not controlled by Google Cloud, right? So the way they route traffic is up to the route, right? So come from right to left, it's saying demo.apphost.com, which goes to the application demo. From there it goes to the service called orders, and then it goes to the version called v1. That's all. But then my router takes control from there. I'm using Express router. So my router, I'm defining that, okay, if I have /health check run this code, it's controlled by Express router. But until that point, it's controlled by Nginx gateway. Outside of this, it's Nginx gateway.
Usually I'll have all of this configuration in maybe server.js and then I just do node space server.
Correct. Yes.
So how is it happening within your application?
Oh, okay. I see what you're saying. Okay, cool. So, good question. It's a catch. You should, I would say, try to stick to this structure. It should see, there are a couple of things it notices in your package JSON. It would expect you to have this script called start. This is the start script is what gets executed when your app, after your app is deployed, when they start your app, right? They run this script called start, and your start says where's your gateway, where's your entry point, like you're saying node server.js. In my case, I just kept it like within this bin www.js is my starting point. And then from there on, it connects to your router and every other module. It loads all of the modules and starts serving the content. So to me, this structure made more sense. I think I pulled it from their examples, I think. I don't remember exactly, but the structure made more sense to me. Like I never touch, like even if in some of the projects that I'm actively working on, if I look at the history of this, there's only one commit. That's it. I never touch this file. This is your gateway, and from here you load, I think you load your router and everything, and then start going from here. Yeah. Yep. It's serving in port 80, and also I think port 8080 is. We can experiment it, changing the port, but I remember I was stuck at that. If you have to run port 8080.
Google Maps, their listeners from
Listeners, yes, yep. So you have to run your app in 8080. You can keep this file anywhere you want, but then make sure to run on 8080 so that you get traffic. All right. Anything else? Good.
Awesome. Yeah.
All right.
Just drop the
Thank you. Yep, I will.
all the way to the top. There's a top left icon.
Oh, this guy.